Imagine this. You step outside one calm evening, the world around you hushed. The air feels lighter, the horizon soft with dusk. Above, the night stretches wide the Milky Way, our home, arcing in silver dust. But hidden beyond that quiet beauty lies motion. Everything you see is drifting, slowly, silently. Even the stars that seem eternal are travelers, and one of them, a giant spiral called Andromeda, is coming for us. It doesn't sound dramatic, because it isn't, not in human terms. The collision won't happen tonight or tomorrow, not even within the life of our species. It is written into the far future, 4 billion years away. But the process has already begun. The space between galaxies is not empty. It's filled with a subtle pull, an invisible conversation of gravity. Andromeda and the Milky Way are partners in that exchange, bound together in a cosmic promise, one that will, eventually, bring them face to face. For now, they move toward each other at about 110 kilometers per second. That's fast enough to circle Earth in less than 7 minutes. And yet, in the language of the cosmos, it is almost stillness. Across the unimaginable void between us, over 2.5 million light-years, the motion is like a slow inhalation. The sky we see tonight is frozen light, messages from the past. Each star, a note in a symphony that has already begun its crescendo. You might think of the universe as vast and quiet, but it is not silent, it hums constantly. The radiation from the Big Bang still ripples through space. The magnetic fields between galaxies twist and shimmer, and within that hum, Andromeda's faint signal grows louder not in sound, but in light. Already, through telescopes, its spiral arms are clear, its core glowing with billions of suns. In the deepest exposures, you can see how its edges blur with ours, a hint of their eventual embrace. If you were to stand here for millions of years, you would watch Andromeda change. At first, it's just a faint smear beyond Cassiopeia, a ghostly oval in the dark. Then, century by century, it swells, its structure sharpens, its light brightens. Over the ages, it will dominate the northern sky, no longer a distant galaxy, but a neighbor arriving at our doorstep. It's a slow, graceful approach, one we might call the universe's most patient dance. And what a dance it is! 2 spirals of stars, gas and dark matter, turning toward each other in perfect, silent symmetry. No one directs them. There is no conductor, no divine hand, only the mathematics of motion, the laws of gravity set long ago. These laws do not rush, they do not falter, they simply unfold, steady as a heartbeat. When you think of collision, you might imagine impact, noise, destruction. But galaxies are mostly space. Even when their arms weave together, the stars themselves will rarely touch. What collides is the invisible. The fields of gravity, the tides of gas, the slow blending of orbits. It will not be a crash, but a merging, a slow blooming of 2 cosmic flowers, their petals of light curling into one another. In the meantime, the night above us remains calm. The stars you know, Vega, Deneb, Altair, continue their quiet drift. The constellations slowly deform, though we cannot see it yet. Over millennia, Orion will stretch, the Big Dipper will twist, and the familiar patterns of myth will dissolve into new shapes. But the human heart is quick to adapt. Future eyes will look up at new constellations and give them names of their own, perhaps no longer hunters and bears, but galaxies and memories. Somewhere in that far future, a civilization, if it still exists, might look up and see a sky ablaze, not with destruction, but with wonder. Imagine the Milky Way and Andromeda filling the heavens like twin spirals of light, their cores glowing gold, their arms tangled in luminous filaments. Night would no longer be darkness, but a river of stars stretching from horizon to horizon. And yet, this is not something to fear. The collision will not end us. By then, the sun will have aged, swelling slightly as it nears the end of its main sequence. Earth's oceans may have long evaporated, but perhaps by then, life, our descendants, or something entirely new will have found other homes around younger suns. The merging galaxies will not bring doom, but renewal. New stars will ignite where gas clouds crash and compress. Nebulae will shimmer with color. It will be a rebirth, not a fall. If you close your eyes, you might picture it, the faint whirl of Andromeda growing larger, the slow ballet of approach, the first tendrils of light touching across the void. Time itself stretches in such imagining. 4 billion years becomes a single sigh. You can feel the smallness of the human story against the cosmic scale, and yet also its connection. The atoms in your body were born in such mergers long ago. Every heartbeat, every breath carries the memory of ancient collisions, stars that lived, died, and gave their ashes to form you. That is the quiet truth behind this story. The universe is not separate from us. The collision of galaxies is not happening somewhere out there. It is happening within the same vast organism of existence to which we belong. You are made of the same dust, moved by the same gravity, illuminated by the same light that will one day blend 2 galaxies into one. So, as you rest tonight, let that awareness soften your thoughts. Let your breathing match the slow rhythm of cosmic time. The universe is vast, yes, but it is also gentle. Every drift, every orbit, every collision follows a pattern of calm inevitability. And you, small and fleeting though you may feel, are part of that pattern. The night above you is not still. It is alive, moving, and endlessly creating. Stars fall into new spirals. Planets form in the shadows. Light travels across the emptiness with messages older than language. Everything changes, yet everything continues. And as you lie beneath that quiet sky, know this: even when galaxies collide, the universe never shouts. It whispers, it unfolds, it begins again. High above the thin blue veil of our atmosphere, 2 spiral giants glide toward one another through a sea of darkness. They have been moving for billions of years, long before the first cell divided on Earth, long before the first spark of thought appeared in a human mind. The Milky Way, our home, our cradle, drifts through space like a luminous whirlpool, 100,000 light-years across. Across the cosmic gulf, the Andromeda galaxy turns in elegant silence, twice as massive, twice as old, its arms wound tight around a brilliant heart. The distance between them is immense, 2.5 million light-years, a gap so wide that light itself takes 25 centuries to cross it. And yet, by the quiet mathematics of gravity, they are destined to meet. Gravity does not rush. It tugs gently, constantly, an invisible thread spun between every atom of every star. Over time, this thread becomes a pull, a drift, then a fall. Andromeda is not flying toward us like a projectile. She is being drawn, serenely, by the same force that keeps your feet on the ground. Astronomers call it the local group dance. More than 50 galaxies, all moving under one another's influence, tracing slow spirals through the dark. Among them, the Milky Way and Andromeda are the 2 titans, each with hundreds of billions of suns, each wrapped in halos of dark matter, extending far beyond what our eyes can see. If you could watch their motions sped up millions of years, flickering by each second, you'd see the 2 spirals edging closer, their halos brushing like ghostly veils. Between them flows a vast river of gas and dust, a medium so thin it would seem like a perfect vacuum, yet it carries the whispers of gravity's approach. Inside each galaxy, stars orbit their centers in immense loops, but those paths are not fixed. Tiny perturbations ripple outward gravitational murmurs, responding to the presence of the other. It is not war in any human sense. It is more like destiny. Two currents in a single ocean, drawn together by the shape of space-time itself. Our Sun, circling the Milky Way once every 230 million years, has already completed nearly 20 orbits since its birth. By the time Andromeda draws near, it will have circled perhaps 10 times more. The stars of both galaxies, unaware of their fate, will continue to spin, shining steadily. To them, the collision will be imperceptible, as natural as a tide. But from the outside, from the patient eye of a distant observer, the transformation will be magnificent. Two luminous pinwheels folding into one another, their arms twisting into tidal streams that stretch for hundreds of thousands of light years. We often call it a collision, but it will look more like a merging of clouds than a crash of solids. Each galaxy is mostly empty space. If two stars passed within 1 billion kilometers, it would be considered an extraordinarily close encounter. The true interactions will happen invisibly. Gravity will distort orbits, fling some stars into the intergalactic night, and pull others into new patterns. The delicate spiral structures will unravel into long tendrils, glowing with newborn stars as gas clouds compress and ignite. Where once there were two, there will be one, a new shape rising slowly from the chaos. But that is still billions of years away. For now, astronomers watch the faint drift, measuring Andromeda's approach through Doppler shifts, subtle changes in light that reveal motion. Each observation is like a heartbeat in a very long life. We can even simulate their future, using supercomputers' digital time machines that let us watch the next 5 billion years unfold in a few minutes. In those simulations, the Milky Way and Andromeda pass through each other several times before finally merging. Each encounter sends ripples of light, waves of star formation, like sparks leaping from colliding embers. Perhaps the most haunting part of this story is its stillness. The collision, when it comes, will be silent. There will be no sound in the vacuum of space, no explosions echoing through the dark. Everything will unfold, slowly, gracefully, in perfect quiet. Even destruction will look like beauty. Stars curving through arcs of gold, nebulae stretching like silk ribbons, black holes spiraling inward toward one another in a cosmic waltz. It is almost impossible for the human mind to hold such scales of distance and time. We measure life in heartbeats, years, generations. Galaxies measure theirs in eons, each moment of ours a blink in their gaze. And yet, this slow inevitability links us to them. The same gravity that binds the moon to Earth is the force that will bind these galaxies. The same physical law that guides a falling leaf governs the paths of stars. It is humbling and strangely comforting to realize that the universe plays by a single set of rules, from the smallest particle to the grandest spiral. Andromeda's approach is not chaos but choreography, a dance written into the structure of space-time itself. So tonight, when you look up, try to imagine it not as catastrophe, but as a story in motion. Somewhere in that patch of sky between Cassiopeia and Pegasus, a neighboring galaxy is gliding closer, slowly, patiently. Its light, leaving there millions of years ago, arrives here as a message from the future. We are coming home. For perhaps that is what this truly is: not an invasion, not an ending, but a reunion. Two halves of a cosmic family drifting back together after an eternity apart. And when they finally meet, their shared light will flood the universe in silence, and the night sky, the very one that watched our species awaken, will open like a flower. Until then, we wait, floating quietly between them, children of the Milky Way, dreaming under the glow of a galaxy already on its way. If you could peel away the stars, the gas, and the glowing arms of both galaxies, what you'd see is something stranger, an unseen web stretching across the void. It's made of dark matter, a substance that neither shines nor reflects, yet outweighs everything visible by a factor of 5. We cannot see it, but we feel it everywhere. It bends light, sculpts galaxies, and binds the universe together like the roots of an invisible tree. It's this hidden lattice that connects the Milky Way and Andromeda long before their stars ever touch. Each galaxy drifts inside a vast halo of dark matter, immense, ghostly, and spherical, extending hundreds of thousands of light-years beyond the visible edge. When these halos overlap, gravity begins its patient work. The two galaxies start to pull not because they decide to, but because the fabric of space-time itself curves inward between them. It's less a collision and more a reunion written into the geometry of the cosmos. Gravity, for all its might, is the gentlest of the fundamental forces. It whispers rather than shouts. It moves mountains, yet takes eons to do so. You can't feel it between your fingers, but it's the reason your body stays anchored to the Earth instead of drifting into the night. And, on a cosmic scale, gravity is the storyteller. It spins galaxies into spirals, lifts gas into stars, and pulls those stars together again when the story is ready to change. Every particle of dust, every photon of light, responds to that quiet curvature. You are, right now, being drawn not just by Earth's pull, but by the collective gravity of the entire Milky Way and beyond that, by the combined mass of the universe itself. It's strange to think that the same invisible thread tugging gently on you is also the force that will one day merge two galaxies into one. If you were to look at the Milky Way and Andromeda through the lens of dark matter, you'd see them as glowing cocoons suspended in a spiderweb of filaments. These filaments stretch for billions of light years, linking clusters of galaxies into something that looks almost alive. Where the threads cross, galaxies form. Where they thicken, entire superclusters arise. The collision between Andromeda and the Milky Way is not random. It's a movement along those ancient filaments, like two drops of dew sliding together on the same strand of silk. Inside each galaxy, gravity choreographs smaller dances. Stars orbit their centers not because they are pulled by one another directly, but because the combined gravity of billions of suns and the vast halo beyond curves space-time into a well they cannot escape. Imagine tossing a marble into a smooth bowl. It spirals toward the center, faster as it nears the bottom. That's what every star is doing, tracing the contours of an invisible landscape carved by gravity's hand. Even here on Earth, you've felt its echoes. The pull of the moon lifts our tides, shifting the oceans with a rhythm older than life. The sun's gravity holds our planet in its looping path, defining seasons, years, and the slow clockwork of time itself. The same principle governs the galaxies. It's only a matter of scale, and in that scaling, there's a kind of unity. The same force that shapes a raindrop also shapes the structure of the cosmos. If you close your eyes, you might imagine the invisible threads surrounding you. They pass through your body, through the walls, through the air unbroken, infinite. They don't stop at the edge of the solar system, or even at the boundary of the Milky Way. They reach out, weaving every planet, star, and galaxy into one single cosmic fabric. When Andromeda and the Milky Way draw near, these threads tighten, resonating with a silent vibration, like the strings of a colossal instrument tuned by time. We once thought space was empty, a void between islands of light. But it isn't empty, it's structured. It carries energy and tension. In the early universe, those threads of dark matter acted as scaffolding, guiding the flow of normal matter, gas, dust, and light into the galaxies we see today. Without them, there would be no Milky Way, no Andromeda, no stars at all. Gravity is not just the glue of the universe, it's its composer, shaping every motion into a grand, slow symphony. You could call it destiny, but it's not a fate imposed from outside. It's simply what happens when matter exists within space-time. Mass bends the space around it, and everything nearby follows that curve. It's a kind of conversation, ongoing and eternal. Stars whispering to one another through distortion and pull. And like all good conversations, it builds connection. Andromeda answers our Milky Way's gravitational call, and we, in turn, are drawn toward her. If you could see this web flicker with light, it might resemble neurons in a vast brain, filaments glowing, nodes pulsing, connections sparking across cosmic distances. Some scientists have even noticed mathematical similarities between the structure of the universe and the structure of the human mind. Perhaps that's why contemplating the cosmos feels so intimate. When we study gravity, we're studying the architecture that also exists inside us. And someday, when the two galaxies meet, the web will tighten, then relax again, forming new shapes, a single, smoother halo surrounding a new, unified system. The threads will not break. They never do. They simply rearrange, weaving a new pattern into the same infinite tapestry. So tonight, if you lie back and stare at the stars, imagine those invisible connections all around you, not lines of fate, but threads of belonging. The earth beneath you, the sun, the stars of the Milky Way, the approaching light of Andromeda, all held in place by the same silent weave. You are not adrift in the universe. You are woven into it. And in that stillness, in that unseeable network of gravity and time, there is peace. The peace of knowing that even across millions of light years, nothing in the cosmos ever truly stands alone. If you could mark the passage of time not in hours or years, but in eons, you would see that the collision has already started. It began long before the first mammals looked up at the night sky, long before Earth's continents found their modern shape. The universe itself has been preparing this meeting for billions of years. The pull between the Milky Way and Andromeda is constant, ancient, and patient, like a slow inhale that will not end for another 4 billion years. In the silence of deep space, distance is not a barrier. It is simply part of the rhythm. Every second, the gap between the two galaxies shrinks by over 100 kilometers. That means in the time it takes you to take a single breath, Andromeda is a few hundred kilometers closer. The movement is invisible to the human eye, too subtle to detect without precision instruments, but it is relentless. Time itself seems slow when measured by gravity, yet its certainty is absolute. If you could speed up the clock of the cosmos, you'd see the first faint tremors of distortion appear in the galaxy's halos. The edges of Andromeda's dark matter field begin to feel the pull of ours, and vice versa. It's as if two vast tides have begun to rise, unseen but inevitable. Within each galaxy, stars continue to orbit, gas clouds swirl, and civilizations, if they exist, gaze upward, unaware that their skies are already changing. The countdown doesn't begin with a crash. It begins with whispers, with invisible gravitational tides that stretch and bend. In the next billion years, our galaxy will subtly warp. Its outer disk will ripple like a sheet of silk in a slow breeze. The graceful spiral arms we admire today will shift position. In Andromeda, the same distortions will occur, both galaxies anticipating one another's presence before they truly touch. Meanwhile, from our small world within the Milky Way, the view will grow more astonishing with every passing millennium. Right now, Andromeda is a faint smear of light, just visible to the naked eye under dark skies. But in millions of years, it will swell like a ghostly lantern in the north, its spiral arms becoming visible to the naked eye. Astronomers of the far future, if such beings still watch, the heavens will see the shape of destiny, approaching night after night, decade after decade, until it dominates the sky. When Andromeda finally appears as large as the full moon, humanity, if it endures, may already have changed beyond recognition. Perhaps we'll have left Earth behind, building new homes among the stars of the outer rim, perhaps will be gone entirely, our traces buried under alien sediments or scattered dust. The universe doesn't hurry for our sake. It moves according to deeper rhythms, cosmic, vast, and impersonal. And yet, there's beauty in that indifference. It means that nothing is lost, only transformed. One day, the two galaxies' outer arms will brush against each other. The first stars will feel the tug, their orbits subtly disturbed, their trajectories shifted. Some will be flung into intergalactic space, drifting alone for eternity. Others will fall inward toward new gravitational centers, forming arcs of light that stretch for hundreds of thousands of light years. From afar, it will look like a slow unfurling, like petals of two enormous flowers meeting in mid-bloom. The process will not be violent in human terms. It will unfold over hundreds of millions of years, each stage so slow that no single observer could witness its progression. Entire species could rise and fall, while the galaxies merely drift a fraction of the way closer. To the universe, it is a blink, but to us, it is the story of forever. As the countdown continues, new possibilities will emerge. Clouds of gas, compressed by tidal forces, will ignite into bursts of star formation. Entire clusters of newborn suns will light up the dark between the merging galaxies. Nebulae will shimmer like faint flames, their colors stretching from pale blue to deep crimson. The collision will not only reshape the structure of the galaxies, but renew them, destruction and creation unfolding in one continuous breath. And in the quiet heart of each galaxy, two supermassive black holes will begin to sense one another. For now, they are far apart, each ruling its own domain, surrounded by whirling stars and streams of hot gas. But gravity feels no distance too great. Slowly, imperceptibly, the two will begin to drift toward the same point, an invisible destiny, waiting at the center of everything. Back here, in our present age, the countdown is invisible, but the evidence is everywhere. The redshift of light tells us the universe expands, yet Andromeda's light is blue-shifted proof that it moves toward us, defying cosmic expansion through the strength of local gravity. It is the only large galaxy approaching the Milky Way. Everything else recedes, carried away by the expansion of space. But Andromeda comes closer. In that, there's something poetic amid the universal drift toward separation. Two islands of light are drawing together. It reminds us of something simple and profound. Gravity doesn't only pull, it unites. Every bond in the cosmos, every orbit, every system of stars or atoms is a story of attraction, of belonging. The galaxies are not colliding because they are enemies, but because they are family. The same force that will merge them is the one that allowed them to exist at all. And so the countdown continues, quiet and eternal. 4 billion years may seem like forever, but to the universe, it's an afternoon. The slow merging of stars, the rippling of cosmic tides, the soft exchange of light across the dark, it is all part of a single unfolding. One day, the Milky Way and Andromeda will be one, their stories inseparable. And somewhere, in the long memory of the cosmos, the echo of their approach will remain, a whisper of inevitability carried on the wind of time. Until then, we drift between them, passengers of a galaxy in motion, unaware that every second brings us a little closer to a new dawn of stars. If you could be there when the moment arrives, the first true meeting between the Milky Way and Andromeda, you would not see a crash. You would see a slow awakening. Two vast spirals of light drifting together, their edges brushing, their arms beginning to braid like threads of silk. There would be no explosion, no sound, only motion, only light. From a human point of view, we might call it chaos. From the universe's point of view, it is balance, a continuation of the laws that have always governed everything. The stars, planets, gas, and dust will move as they must, obeying gravity's choreography with absolute grace. Each orbit will shift, each system will find a new home, and nothing will happen that the cosmos did not already allow. When the galaxies first touch, their outer halos meet long before their visible disks do. Invisible tendrils of dark matter intertwine, merging into a single gravitational field. The gas clouds at the edge of each galaxy collide next, compressing and glowing with heat. Hydrogen atoms, squeezed together by cosmic pressure, begin to fuse, and new stars are born by the millions. From afar, this looks like fireworks in slow motion. Tiny points of blue light flickering into existence across the merging arms. This first passage will last hundreds of millions of years. The galaxies will stretch each other into long tidal tails, ribbons of stars flung into intergalactic space, curving like luminous rivers. Some of those stars will never return. They will drift forever, wandering through the void between galaxies, carrying with them the memory of two once separate worlds. Others will fall back, their orbits decaying, spiraling toward the center of the growing merger. Our sun, depending on chance, may be among those that are cast outward. As the gravitational patterns shift, entire systems like ours could be slingshotted into the outer reaches of space. If humanity or any descendants of life from Earth still exist then, they might watch their familiar sky transform completely. Constellations would dissolve, replaced by strange new patterns. The night would no longer belong to the Milky Way, but to a sky bursting with the glow of two galaxies becoming one. Andromeda's brilliant core will stretch across the heavens like a second dawn. Stars will flood the horizon, thousands of times brighter than the faint band of the Milky Way we see today. Imagine looking up and seeing entire clusters of suns, nebulas the size of continents, and streaks of light that arc across the sky for months at a time. The universe will no longer look empty. It will look alive, radiant, and endlessly shifting. But such beauty carries quiet destruction too. Massive gas clouds will collide, forming stars so quickly that their light will burn hot and short. Supernovae will detonate in every direction, scattering heavy elements across the newborn galaxy. Black holes will feed more greedily than ever, devouring nearby matter and releasing jets of radiation that streak through space. Yet even this violence is creation in disguise. Those supernovae will forge carbon, oxygen, iron, the ingredients of life, scattered like seeds across the stars to come. As the galaxies pass through one another, their shapes will distort. The graceful spirals will twist into tangled ellipses, their cores swinging apart before gravity pulls them back again. The first encounter will not end in union, but in retreat, a slow, majestic separation that sets the stage for the second meeting. They will fall toward each other again, drawn by the same force that never lets go, and their paths will cross once more. Each passage will strip away a little more of their individuality. The Milky Way's arms will lengthen, Andromeda's will fray. Streams of stars will connect them like luminous bridges. Slowly, their centers will align, and the two galaxies will settle into one another's embrace. Astronomers call this process galactic merging, but the term hardly does justice to its poetry. It is less a collision than a blending, a cosmic breathing in. And what of our solar system, drifting inside this vast event? By then, the sun will have aged into a swollen red giant, its light warmer, redder, and dimmer. The Earth, if it still exists, may have been stripped of its oceans, its surface scorched. Yet beyond our small world, life may continue elsewhere, perhaps around other stars, perhaps in forms unimaginable to us now. If they have eyes to look upward, they will witness the birth of a new sky. From the perspective of deep time, this moment of contact will be fleeting. After several billion years of movement, the galaxies will merge completely, forming a single, massive, elliptical galaxy that astronomers already have a name for, Milky Way. It will be smoother, rounder, and older than either of its parents. Its stars will orbit not in graceful spirals, but in random paths, like dust swirling in golden light. It will shine brighter than any galaxy in our local group, a testament to everything that came before. But before that calm end, there will be wonder, a celestial storm of beauty. Entire constellations will be torn apart and remade. Black holes will dance together, spiraling inward, until they merge with a burst of gravitational waves rippling across the universe. Those waves, stretching space-time itself, will travel outward forever, carrying the signature of two galaxies that once met in silence. In the end, the universe does not destroy, it transforms. What we call collision is simply another form of creation. When galaxies touch, they write new stories in light tales of gravity, time, and renewal. The stars themselves will forget where they began, but their glow will carry the memory forward. If you were to watch from a safe distance, say, from another galaxy millions of light years away, you would see it unfold like a slow, luminous ballet. Two spirals drift closer, touch, pull apart, and finally merge into a single sphere of radiant calm. No sound, no fury, only the endless rhythm of expansion and return. And perhaps that's the most remarkable truth of all, that even in collision, the universe remains gentle. Stars move as they must, light travels as it should, and the cosmos breathes in, out, in again for eternity. So if you find yourself thinking of destruction, think instead of creation. When galaxies touch, they do not end. They begin again, brighter than before. Picture the scene a billion years after that first encounter. The Milky Way and Andromeda are no longer distant spirals, but tangled partners in a slow cosmic waltz. Their arms, once perfect and symmetrical, have stretched into luminous ribbons, arcs of stars and dust, drawn out by invisible gravitational tides. Each ribbon glows faintly, curling into the dark like the trails of ancient fireworks. It's a dance so vast that no eye could ever see it whole. Yet if you could step outside the universe for a moment and look back, you would witness something unspeakably graceful. Two galaxies moving as one, their stars pirouetting through the void. This is what happens when gravity becomes choreography. Each star, though separated by light years, feels the pull of millions of others. Together, they form patterns of motion that are both chaotic and precise, the universe's most intricate dance. Some stars are flung outward, hurled into intergalactic space at speeds of hundreds of kilometers per second, becoming cosmic nomads that will never again belong to any galaxy. Others dive inward, swept into new orbits around the merging cores, tracing elliptical paths that stretch and tighten with every turn. The beauty of this ballet is not in its speed, but in its patience. Every gesture unfolds across millions of years. Each twist of light, each ripple of starlight, takes longer than the entire history of human civilization. And yet, there's rhythm in it, a tempo as steady as breathing, as natural as tides on an unseen ocean. Gravity is the music, and every star knows the steps. From our perspective, somewhere within one of the spiraling arms of the Milky Way, the sky will begin to change. Constellations we once knew, Orion, Cassiopeia, the Swan, will distort beyond recognition. The horizon will bloom with unfamiliar lights, clusters of Andromeda's stars scattered like pearls against the black. If there are still eyes to look upward, they will see the sky brightened by entire star fields, the night no longer a darkness but a living canvas of motion. In some regions, the glow will be so great that true night may disappear altogether. The combined brilliance of billions of suns will paint the heavens in hues of gold and sapphire. Great arcs of light will cross from horizon to horizon, the visible scars of gravitational tides stretching through space. For any world still orbiting a star, The view will be both terrifying and transcendent, creation and collapse playing out in silence. The tidal forces shaping this cosmic dance are relentless. As the galaxies weave through each other, their mutual gravity pulls stars into elongated streams. Astronomers already see similar remnants elsewhere. The antennae galaxies, for example, caught in their own embrace, throwing out long, luminous tails that shimmer like wisps of smoke. These tails are the signatures of union, the footprints left behind when two spirals meet. Within these streams, gas clouds collide and compress, igniting waves of starbirth. Entire clusters are born in the chaos, hundreds of thousands of suns shining newborn light into the dark. To a distant observer, the merging galaxies flicker with blue, the color of youth in the cosmos. Every blue star is short-lived, a candle that will burn fiercely for only a few million years before fading into white ash. But during that brief existence, it will illuminate the paths of countless others, marking the invisible curves of gravity's design. As the galaxies continue to intertwine, their centers begin to spiral closer. The gravitational pull grows stronger, shaping the orbits of billions of stars into sweeping ellipses. It's as if the universe is gathering its energy for a final movement, the grand finale of its dance. The stars themselves may never collide, but their collective motion generates waves through the fabric of space-time ripples that radiate outward, carrying the story of this encounter to the farthest reaches of the cosmos. If you could listen to those ripples, if gravity had sound, you might hear a deep, resonant hum, a song of merging mass. Physicists have learned to detect such ripples from black holes and neutron stars, but a galactic merger would sing in notes too low for any instrument we can yet build. Still, the melody exists, the song of gravity played across billions of years, echoing through the silence. Meanwhile, within the chaos, balance begins to form. The random motions of stars start to smooth into a single system. The tidal tails, once stretched and wild, slowly arc back toward the forming core. The two galaxies, having danced through one another, now begin to settle into a shared rhythm, and out of the tangle of light, a new shape emerges. Not spiral, but oval, a prelude to the birth of a new galaxy entirely. For the first time, the Milky Way and Andromeda are no longer distinct. Their halos, their gas, their stars are one. The tidal ballet has ended its first act. From this point on, every orbit, every rotation, every shimmer of light belongs to the same cosmic being. It's as if two souls have merged, not destroyed each other, but found completion. In the vastness of space, no one witnesses this moment directly. No consciousness observes it unfold in real time. And yet, it happens all the same, a secret performance in the theater of the universe. The stars do not need eyes to be beautiful. They dance for the sake of motion itself. And when the final ribbons of starlight fade, when the last stray suns fall into the growing central sphere, what remains is quiet again. The collision that began as chaos ends as calm. The new galaxy drifts, shining softly in the dark, carrying within it the memory of two that became one. If the universe could speak, it might whisper this truth: nothing that collides in harmony is ever lost. Motion becomes pattern, pattern becomes form, and form becomes beauty, infinite and unbroken. So when galaxies touch, they do not end their dance, they simply change the rhythm. The music continues, echoing through the dark, a timeless waltz written in gravity and light. Before the stars of the Milky Way and Andromeda ever intertwine, something deeper and stranger begins to merge first, the invisible halos of dark matter that surround them. These halos are enormous, stretching far beyond the bright spirals we can see. They are the true skeletons of galaxies, silent frameworks made not of atoms, but of something mysterious, something that neither emits nor absorbs light. If you could somehow paint the darkness, you would see them two colossal spheres of shadow, overlapping long before their luminous hearts ever touch. This is the meeting of darkness with darkness. Not a collision in the way we know it, but a blending of gravitational fields, a slow folding of invisible substance into a single shared shape. No telescope can show it. We infer its presence only by its pull, by the way it bends the paths of stars and light. To watch galaxies merge is to watch ghosts embrace intangible, yet undeniable. Dark matter makes up nearly 85% of all mass in the universe. It doesn't shine, it doesn't glow, but it holds the cosmos together. Without it, stars would fly apart, galaxies would unravel, and the universe would be nothing but scattered dust. When Andromeda and the Milky Way approach, it's their halos of dark matter that meet first, overlapping across millions of light years like two oceans of gravity. Where they merge, the pull intensifies, deepening the well of space-time itself. Everything within stars, gas, even light begins to feel that deepening tide. Imagine floating at the boundary of this invisible sea. There are no waves, no color, no sound, yet everything around you moves. The dark matter flows, silent and cold, shaping orbits, slowing motions, drawing all things inward. It is not an enemy, not a destroyer. It is the quiet architecture of the universe, unseen but absolute. You live within it now. Every atom in your body swims through dark matter every second of every day. You cannot feel it, but it feels you, exerting a pull that connects you to everything else in existence. When these two halos merge, they form the first outline of the new galaxy to come. Even as the bright disks of stars are still far apart, the dark matter has already begun weaving them together. It's like the foundation of a house rising before the walls are built invisible, but essential. This union of darkness determines the fate of all that follows. The paths of the stars, the shapes of the tidal tails, even the eventual calm of the future elliptical galaxy are written here in the mathematics of unseen mass. For scientists, dark matter is still one of the universe's greatest mysteries. We don't know what it's made of. Perhaps exotic particles, perhaps something even stranger. We only know that it behaves like a gravitational ghost, influencing everything but remaining forever hidden. And yet, in this grand merger, it plays the starring role. The collision between Andromeda and the Milky Way is not merely about stars meeting. It's about these two invisible oceans blending into one. If you could accelerate time, watch billions of years pass in a few minutes, you'd see the halos ripple and settle like merging ink clouds. The edges blur, the centers thicken, and soon there is no boundary at all. Within that vast, invisible cocoon, the bright cores of the galaxies begin their slow fall toward one another. It's as if the darkness itself is drawing the light together, the unseen pulling the seen into its arms. To think of darkness as gentle might feel strange, but that's exactly what it is here. There's no violence in its touch, no explosion or shockwave. Only gravity, the most patient force in existence, sculpting order out of motion. When the halos merge, energy is redistributed. Some stars gain speed, some lose it, but the overall harmony remains. The invisible structure holds everything steady, even as the visible world reshapes itself. Perhaps it's fitting that the universe hides its greatest beauty in what we cannot see. We look up and marvel at starlight, yet the real miracle is the unseen framework beneath it, the quiet architecture that lets stars exist at all. The collision of galaxies is only half visible. The other half happens in shadow, in the vast gravitational dialogue of dark matter. And maybe, in some distant sense, we carry that same truth within ourselves. What we show to the world, our light, our motion, is only the visible half of what we are. Beneath it lies the unseen. Memory, thought, gravity of emotion. Just as galaxies merge from the inside out, so do we. The visible follows the invisible. When darkness meets darkness, something remarkable happens. Light follows. The gravitational compression caused by merging halos will spark waves of star formation later on. The invisible collision births visible fire. From shadow, stars will bloom. It is the oldest story in the universe, creation emerging from what cannot be seen. So, as the Milky Way and Andromeda continue their slow approach, their dark halos already entwined, the stage is set. The galaxies may not yet appear to touch, but their fates are sealed. In the stillness between them, gravity is writing the next act, a poem in the language of mass and motion. And though we will never see this union with our eyes, we can feel its meaning. The universe is not built from light alone. It is built from the embrace of things unseen from darkness that holds, connects, and creates. When darkness meets darkness, the stars prepare to be born. By the time the galaxies truly begin to overlap, the universe will appear to bloom. What once seemed like the calm sweep of stars will erupt into a wave of creation, a burst of brilliance spanning thousands of light years. From a distance, it will look like fireworks, a slow and luminous explosion stretched across millions of years. But unlike the fleeting sparks that color our skies, these cosmic fireworks will burn for ages. Every flicker will be a new sun, every shimmer a newborn world. This is the paradox of galactic collisions. From destruction comes beauty, and from chaos comes life. When Andromeda and the Milky Way intertwine, their vast clouds of hydrogen gas will collide and compress. In the dense knots where the pressure is greatest, gravity will begin to fold matter upon itself until fusion ignites. 1 billion new stars will blaze to life, outshining entire regions of their parent galaxies. The dark, dusty arms that once circled quietly will suddenly glow blue-white, the hue of youth and energy in the cosmos. If you could watch from a distance, perhaps from the outskirts of a smaller galaxy nearby, you'd see an extraordinary sight. The merging spirals would flare like lanterns in the night, their centers pulsing with light. Great arcs of gas and dust would curl outward, forming shimmering bridges between the galaxies. Streams of newborn stars would flow along those bridges, glowing faintly against the black. It would be like watching a slow, cosmic sunrise, the darkness gradually replaced by color and radiance. But up close, inside one of those newborn star clusters, the view would be both awe-inspiring and perilous. Massive blue suns would dominate the sky, burning with furious intensity. Their light would be so strong that it could cast shadows even on the night side of nearby planets. But such stars live fast and die young. Within a few million years, many would collapse, detonating in spectacular supernovae that scatter heavy elements, iron, calcium, carbon, into the surrounding space. These elements will drift, cool, and later form the seeds of new planets, perhaps even new life. The process is both creation and renewal. Galaxies are not static. They grow and change like living things. Collisions like this one are the engines of cosmic evolution. They recycle old matter, ignite dormant gas, and fuse ancient structures into new ones. Without collisions, the universe would grow dim and cold, a gallery of galaxies aging in silence. Instead, it remains vibrant, continuously remade by gravity's invisible hand. Our own Milky Way bears scars of past encounters. The faint streams of stars that wrap around it are remnants of smaller galaxies long absorbed. Even now, new mergers are happening at its fringes, though we are too small to feel them. The upcoming meeting with Andromeda is simply the next and grandest chapter in a long story of cosmic renewal. Imagine watching the transformation unfold from within. For millions of years, the night sky would shimmer with strange lights. Nebulae would bloom like flowers, glowing pink and gold as ultraviolet light from new stars excites their gases. Dust clouds would twist into serpentine shapes, illuminated from within. To any surviving worlds, the heavens would be breathtaking, a celestial ballet of color and fire, played out in total silence. The silence, though, would be deceptive. Inside those clouds, matter rages, temperatures soar, gravity crushes, and radiation floods through the void. Yet from this chaos come the elements of order. The explosions of dying stars enrich the galaxies, scattering the raw ingredients for life into the dark. In a few billion years, new solar systems may rise from the ashes of this merger, circling suns that did not exist before. Somewhere in the far future, new beings may look up at their skies and see faint traces of the galaxies that once were their own ancestors written in starlight. Every burst of creation will have its counterpart in silence. Between the bright clusters, regions of gas will be swept clean, vast voids where star formation ceases. The energy of the collisions will carve cavities into the interstellar medium. Bubbles of calm, surrounded by rings of fire. These contrasts, emptiness beside brilliance, darkness beside light, will define the new galaxy's structure. Even as chaos unfolds, the universe finds symmetry. If you were to compress this entire process billions of years into a single human lifetime, you would see the galaxies flicker and flare like candles in a storm. Each pulse of light would mark a new generation of stars, each fading glow a death. The entire event would resemble breathing the universe, inhaling light, exhaling darkness. It's the same rhythm found in everything from the beating of a heart to the birth and death of suns. This slow, cosmic firework display will mark the middle act of the merger. After the initial bursts, the rate of star formation will gradually decline. The galaxies will begin to calm. The once bright bridges of light will fade, replaced by a single, vast structure glowing softly in equilibrium. What began as two will now exist as one heavier, brighter, more complete. Even then, the echoes of this event will ripple outward forever. Every ray of light, every gravitational wave will carry the memory of this luminous meeting through the cosmos. And perhaps, in some far corner of the universe, another observer on another world will see those distant flares and wonder, what just bloomed in that quiet patch of sky? They would not know they were watching the rebirth of our home. And so, the cosmic fireworks fade, leaving behind the afterglow of creation, a new galaxy rising from the slow and silent beauty of destruction. The universe, once again, will have made something new from its own fragments. It will breathe out, and then, patiently, begin again. At the center of every great galaxy lies a secret, a massive, invisible engine that anchors its stars and dictates its rhythm. These are supermassive black holes regions where gravity has collapsed matter into an infinite point, where not even light can escape. In the Milky Way, this hidden heart is called Sagittarius A, asterisk, a monster, 4 million times the mass of the Sunday. In Andromeda, its counterpart is even larger, weighing nearly 100 million suns. For billions of years, they have ruled their domains quietly, each surrounded by a glowing disk of dust and gas, each feeding in silence. But now, as the two galaxies spiral closer, their destinies begin to intertwine. The stars, nebulae, and dark matter halos may be merging in slow motion, but deep in their centers, something far more dramatic is unfolding. The gravitational pull between the two black holes begins to tighten, like an invisible thread, drawing them together across the void. At first, they circle from afar, each enclosed in its own region of chaos. Over millions of years, the friction from swirling gas, and the combined gravity of billions of stars will drag them closer and closer. The first encounter will be subtle. Each black hole disturbs the other's surroundings, bending space, twisting orbits, heating gas until it glows with X-rays. A vast accretion disk forms, shining with the brightness of 1 trillion suns. Around it, stars will be flung outward in great arcs, their paths distorted by the immense gravity of 2 converging singularities. To an observer from a safe distance, it will look as though the centers of the galaxies are burning, their hearts pulsing with blue-white fire. The closer they spiral, the wilder the dance becomes. Like 2 whirlpools merging in a stormy sea, their gravitational waves ripple through space itself, distorting time in delicate vibrations that spread across the cosmos. Each orbit draws them inward, faster and faster, their separation shrinking from light years to mere light days, then to the span of our solar system. When the distance finally narrows to a few light hours, the entire universe will tremble. At that moment, no light will escape, but the energy released will be unimaginable. The merging black holes will convert a few % of their total mass into gravitational waves, pure ripples in the fabric of reality. For a brief instant, the power output will exceed that of all the stars in the observable universe combined. Yet no one will hear it. There will be no explosion, no sound, only the gentle flexing of space-time, passing invisibly through everything. The final collision, when it comes, will be quiet and absolute. The 2 singularities will merge into one, forming a single, even more massive black hole at the heart of the new galaxy. Its spin will be furious, its event horizon shimmering within falling gas. For a while, it will flare like a beacon, a quasar, one of the brightest objects in the universe. Jets of plasma will shoot from its poles at near light speed, piercing the darkness like cosmic lighthouses. Then, as its appetite wanes, it will calm, leaving behind only a faint X-ray whisper, a sleeping giant resting at the center of Milky, the newborn galaxy. This merging of hearts is more than spectacle. It is the mechanism by which galaxies grow old gracefully. The gravitational energy released in such collisions redistributes the stars around them, helping the chaotic galaxy settle into a smooth, elliptical form. What began as violent motion becomes balance once more. The stars that survive will orbit this new center of gravity in harmony, tracing elegant ellipses through the quiet aftermath of creation. If life still exists anywhere within this galaxy, its night sky will be extraordinary. Far above, the core will glow with a radiance unlike anything seen before, a bright golden sphere at the center of everything. From the outskirts, it will look like a permanent sunrise hanging in the heavens. The shadows on those worlds will always point toward that light, as if the cosmos itself were paying tribute to its new heart. But beneath that serenity lies the ultimate paradox. The most destructive forces in existence have created the most stable structure imaginable. 2 infinities have cancelled one another, and in doing so, have given birth to calm. It's the universe's quiet way of telling us that even annihilation can lead to harmony, that endings are not destruction, but transformation. Some physicists call this moment the heartbeat of galaxies. Others think of it as a kind of reset, the point where time and gravity reconcile their eternal tension. Yet beyond the equations and theories, there's something deeply poetic in it. The cosmos does not merely collide, it breathes. It contracts, expands, and rests again. Like a living being whose pulse we can barely comprehend, the merging of black holes will mark the climax of the collision, the universe's most private event. No human eye will see it, no instrument will capture it perfectly, but the ripples it sends will echo through space forever. Millions of years later, they may wash across other galaxies, bending starlight, altering the paths of dust and gas, whispering faintly of a time when two hearts became one. And after that, silence. The newborn black hole will sit at the center of the universe's memory, patient and eternal. Around it, the remnants of two galaxies will continue their slow dance, orbiting in peace. The violent energy will fade, the light will soften, and the cosmos will return to stillness. The hearts of the Milky Way and Andromeda will have fulfilled their destiny not by conquering, not by consuming, but by uniting into something greater than either alone. That is how galaxies end. That is how galaxies begin. In the hush that follows, light continues to travel outward, carrying with it the story of their union, the final verse, in a song written by gravity itself. If you listen closely enough, you might still hear it. A whisper through time, a heartbeat beneath the stars, the quiet proof that even in the deepest darkness, something always becomes whole again. When the last echoes of the galactic collision fade, when the final streams of stars settle into new orbits, a new being will emerge from the silence, a single, vast, luminous creature of light and gravity. Astronomers already have a name for it: Milkomeda, the child of the Milky Way and Andromeda. It will be unlike either of its parents. The graceful spirals that once stretched like arms across the sky will vanish, replaced by a glowing oval of stars adrift in cosmic calm. From the outside, Milkomeda will shine brighter than any galaxy in our local group. Its heart, forged by the merging of two supermassive black holes, will radiate with faint golden light. Around it, hundreds of billions of suns will trace slow, intricate paths, some newly born from the chaos of collision, others survivors from the ancient galaxies that gave them life. Where once there were two families of stars spinning separately, now there will be one unified system, massive, tranquil, and timeless. For a long while after the merger, the galaxy will remain restless. Tidal tails, long ribbons of light, will still stretch into space, fading like after-images of motion. Clusters of stars will drift in graceful arcs, slowly falling back toward the center under the pull of gravity. But with each passing 100 million years, Milkomeda will grow smoother, its edges rounding out as the last remnants of collision dissolve into balance. The violence of the past will leave no scars, only symmetry. The transformation from spiral to elliptical is more than cosmetic. It's a sign of maturity. Spirals are galaxies in motion, fueled by cold gas and ongoing starbirth. Ellipticals, by contrast, are old souls. Their gas is spent, their star formation quieted, their orbits randomized. They shine with the soft, amber glow of ancient suns, stars that have burned steadily for billions of years. Milkomeda will embody that stillness, a galaxy in peaceful equilibrium, its youthful chaos transformed into order. Inside this new world, the night skies of surviving planets will be beyond imagination. The view from any one of them will not be the delicate ribbon of the Milky Way we know, but a vast golden sea overhead, an unbroken dome of light. The density of stars in the central regions will be so great that the heavens will shimmer with perpetual twilight. Shadows will exist, but darkness will not. If life arises there, its creatures will never know a truly black night. Their myths will not speak of the stars as distant points, but as waves of light that never end. At the outer edges of Milkomeda, the story will be different. There, far from the glowing heart, ancient stars will drift in lonely orbits. Many will be exiles flung outward by the chaos of the merger, wandering at the boundaries of the new galaxy. Some may even escape entirely, cast into the intergalactic dark, to drift forever between worlds. These stars, scattered and silent, will be like forgotten memories, the last reminders of the galaxies that once were. Yet, even in its calm, Milkomeda will still change. Its black hole at the center, now perhaps hundreds of millions of solar masses strong, will continue to feed occasionally, consuming stray gas and unlucky stars. Each time it does, it will flare briefly, shining brighter than all its stars combined before fading again into rest. Around it, globular clusters, ancient, spherical swarms of stars will orbit like satellites, relics of an earlier cosmic age. From a far vantage point, the new galaxy will be breathtaking. It will appear as a smooth ellipse of soft light, glowing in hues of gold and amber, surrounded by faint wisps of blue, where younger stars still flicker. To any civilization, observing it from millions of light years away, Milky will seem eternal, serene, and complete, unaware of the violent story that created it. And yet, deep within its calm, history will still whisper. The orbits of some stars will bear subtle irregularities, reminders of the tidal forces that once tore the galaxies apart. The distribution of dark matter will still carry the imprint of two halos that once met and merged. Even the chemical fingerprints of its stars will tell the tale. Some rich in heavy elements from Andromeda's past, others more pristine, born from the Milky Way's older gas. The new galaxy will be a mosaic of histories, a fusion of time itself. Billions of years later, the universe around Milky will have changed too. The cosmic expansion will continue to accelerate, pushing distant galaxies farther and farther away. Eventually, they will slip beyond the horizon of visibility, their light stretched so thin by the growth of space that it will never reach us again. In that far future, Milky will stand almost alone in a darkening cosmos, surrounded only by the faint remnants of its own stars. It's strange to think that, one day, this great union will be all that remains visible. The descendants of future astronomers, if any still exist, will look into the sky and see only their own galaxy, unaware that once the universe was full of neighbors. The stars of Milky will be their entire cosmos, their horizon of wonder and mystery. Yet even isolation has its poetry. In that quiet future, the galaxy will shine against the growing darkness of eternity, a single island of light floating in an expanding sea. Within it, countless worlds may circle their suns in peace, their skies forever glowing with the memory of creation. That is the destiny of Milky, not destruction, but permanence. It will outlive its makers, outshine its ancestors, and drift through the ages as a monument to the quiet power of gravity. The Milky Way and Andromeda will be gone, their names forgotten, but their essence will remain joined forever in a single luminous breath. And perhaps, if the universe itself could remember, it would recall that once, long ago, two galaxies met in the silence of space and became one not through violence, but through grace. The light of their union will travel forever, carrying a message older than life itself, that even in a universe built on impermanence, something vast and beautiful can still endure. If Earth still exists, when the galaxies finally draw close, the heavens above it will bear no resemblance to the sky we know tonight. Constellations, those fragile outlines drawn by human imagination, will have dissolved into unrecognizable patterns. Orion's belt will scatter. Cassiopeia will stretch and fade. The Big Dipper will twist into something unnameable. The sky will no longer be a familiar map of ancient myths, but a living panorama of motion, every star a wanderer, every night a slow transformation. Far above, Andromeda will no longer be a faint smudge, seen only through telescopes. It will dominate the horizon, a vast whirl of light expanding across the heavens. At first, it will appear as a pale, elongated glow, then as a structured spiral whose arms twist like ghostly rivers of stars. Over millions of years, it will swell until it spans the entire sky, its core radiant and golden, its edges brushing the faint outline of the Milky Way's own disk. To any creature still alive to witness it, the view will be sublime, a double galaxy suspended above the world, two immense storms of light, silently approaching each other across the night. Imagine standing on some quiet shore, the air thin, the seas shallow, the continents changed by time. The sun, by then older and hotter, will burn redder in the sky, and the Earth's oceans may already be retreating into vapor. Yet in the cooling twilight, the sky will blaze with a brightness never before seen. The merging galaxies will cast enough collective light to turn night into perpetual dusk. Their arms will arc like silk ribbons from horizon to horizon. The shadows of mountains will stretch not by the light of a moon, but by the faint shimmer of billions of distant suns. If life has survived this far, perhaps moved underground or adapted to the growing heat, its descendants might emerge at night to watch the slow unfolding above. To them, the sky would not be terrifying but divine, a celestial event beyond comprehension. Perhaps they will record it in symbols, draw it on stone, or whisper to one another of a time when two great fires in the heavens met and became one. What ancient humans once imagined as gods of creation and destruction would now play out before their eyes, real and magnificent. The merging of the galaxies will continue over hundreds of millions of years. With each passing epoch, the view from Earth will change subtly but endlessly. First, Andromeda's arms will become distinct spirals, visible even in daylight. Then, as the galaxies draw closer, immense arcs of light will streak across the heavens, luminous bridges of stars connecting the two. Later still, when their cores finally align, the sky will erupt in color-faint pinks and blues from glowing nebulae, golden streams of dust lit by newborn suns. The entire vault of heaven will look alive, like the surface of an ocean illuminated from within. There will be no true night then. The Earth, if it still circles the dying sun, will bask under a galaxy of its own creation. The starlight will be strong enough to cast permanent shadows. Even the dark side of the planet will shimmer faintly, painted by the glow of the cosmic storm above. The Milky Way we once knew, a delicate band of light, will have become something far greater, a celestial continent, vast and luminous, stretching across the firmament. Astronomers, if any remain, will watch the transformation with awe and melancholy. They will know that their home galaxy is dying and being reborn at once. Their instruments will record the slow migration of stars, the stretching of space, the final merging of two ancient lineages of light. And perhaps they will understand something that we, in our brief age, can only glimpse, that the cosmos, for all its violence, always moves toward harmony. In the midst of this spectacle, the fate of Earth itself will hang in quiet uncertainty. Some simulations suggest our solar system may be flung outward into the galaxy's outer halo, cast adrift among the remnants of the merger. Others predict it will find a new orbit closer to the galactic core, surrounded by fresh stars and nebulae. Either way, our world will travel through skies, unlike any it has ever known, wandering through seas of light that shimmer and change for eons. If our sun has already expanded into a red giant, Earth's surface may be scorched or stripped away, leaving only its rocky core. Yet the night, or what remains of it, will still carry the memory of our beginnings. The atoms in those rocks, in that soil, were once forged in stars of both galaxies. The same elements that made us will be scattered again, perhaps to form new worlds elsewhere, under skies born from this great union. One might wonder if any beings will still exist to witness that final sky beings who can look up, feel wonder, and ask questions. It doesn't matter whether they are human or something else. What matters is that the universe will still be observed, still be seen. For the cosmos, observation is a kind of memory. Each gaze, each thought, is the universe reflecting upon itself. And when those distant minds look upward and see two galactic hearts blending into one, they will not see destruction. They will see a kind of creation older than time, a slow, radiant merging, that turns chaos into art. The sky will not end. It will simply become new. When they raise their eyes to that golden ocean of stars, they will see not the death of a galaxy, but its transformation, a reminder that even in the face of unimaginable change, beauty endures. The night will no longer be a place of darkness, but a cathedral of light, the final gift of the Milky Way to its future children. And perhaps, in some quiet way, the universe itself will smile, knowing that even after billions of years, its story still finds a way to shine. It sounds impossible. Two galaxies, each containing hundreds of billions of stars, drifting into one another, yet not a single direct collision between those stars will occur. It feels counterintuitive, as if the universe itself were playing a trick of scale. But this is the quiet truth of cosmic geometry. Space is vast, almost inconceivably empty. Even in the densest regions of our galaxy, the average distance between two stars is trillions of kilometers. If a star were the size of a coin, its nearest neighbor would still be hundreds of kilometers away. That emptiness is what makes this grand cosmic dance so strangely serene. When the Milky Way and Andromeda meet, their spiral arms will interlace, their shapes will distort, and their centers will merge. Gas clouds will crash into gas clouds, sparking bursts of star formation, yet the stars themselves will glide past one another like grains of sand in a cosmic breeze. The galaxies will not burn, they will shimmer. They will not explode, they will unfold. Each star will obey gravity's choreography. As the galaxies merge, the combined gravitational field will pull stars into new paths. Some will be cast into wider orbits, others drawn closer toward the forming core. A few will gain enough velocity to escape entirely, exiled into intergalactic space where they will drift alone for eternity. Isolated suns shining into nothing. But for the vast majority, the process will be gentle, even graceful. The stars will weave through one another, bending their trajectories as if performing a silent dance scripted by time itself. From afar, it will look chaotic ribbons of light, stretching and swirling in unpredictable arcs. But on the scale of individual stars, it will be peaceful. The distances are simply too great for collisions to happen. A typical star is so small compared to the space it inhabits that the chance of two directly striking one another during the merger is astronomically low, roughly 1 in a trillion. Even when entire galaxies collide, the likelihood remains almost zero. Yet, while the stars won't crash, their worlds might not be so lucky. The gravitational reshuffling could disrupt the delicate orbits of planets around their suns. Some may be flung into frozen exile. Others may spiral into fiery destruction. Entire solar systems could be torn apart, their histories erased in silence. But others will survive, adapting to new skies, new neighbors, new orbits beneath unfamiliar constellations. The universe is nothing if not patient. It gives, and it takes with equal grace. What's extraordinary is how stable all this chaos becomes. As the galaxies merge, their stars will settle into a new equilibrium, their orbits rearranging into the calm, elliptical symmetry of Milky Way. Over hundreds of millions of years, what began as disorder will transform into balance. The new galaxy will not remember its collision as violence, but as a moment of creation. Astronomers often simulate these mergers using supercomputers, compressing billions of years into a few minutes of virtual time. Watching the data unfold feels almost spiritual. Two spirals approach, their shapes twisting and stretching, and then instead of impact they pass through one another like ghosts. Their arms ripple, forming luminous bridges of stars. The first encounter sends shockwaves through their structure, but nothing burns, nothing breaks. They swing apart and fall together again, drawn by the invisible tether of gravity, until finally they fuse into one glowing whole. It's a breathtaking reminder that the universe's greatest transformations often happen without destruction. Even in the thick of the merger, the sky from any surviving world would be serene. The stars would drift slowly, not crash. Constellations would dissolve and reform, the horizon glowing with strange new lights. But there would be no sense of violence. The heavens would not roar, they would whisper. Each star would move in slow arcs, pulled gently into new relationships with others, tracing the invisible currents of space-time. If you could stand on a planet orbiting one of those stars and look up, you would see the proof of this quiet miracle. Across the night, a river of light would stretch, wide and luminous, not from fire, but from alignment. Stars from two galaxies, mingling in view, blending their brilliance into one vast celestial ocean. It would be like living inside a painting that changes imperceptibly with every passing millennium. There's something deeply humbling about this. We often think of collision as violence, of transformation as loss, but in the universe, change rarely destroys. It redistributes, it reshapes, it renews. The stars that survive the merger will continue their long journeys, orbiting within the gravity of a new home. Their light will combine to create something greater, smoother, more luminous, the steady glow of Milky. It reminds us that even in the grandest events, the universe keeps its peace. Its laws are constant, its music continuous. The galaxies move through one another not as enemies, but as partners in an infinite waltz. Each motion is measured, each outcome inevitable. And, as their stars glide by, untouched, unharmed, unhurried, the universe itself seems to sigh. Nothing breaks, nothing ends. Only the shapes change, and the light continues its quiet journey. So when galaxies collide, the stars do not scream through the void. They drift, they dance. They make something new, without ever touching proof that even in a universe built on gravity and fire, harmony remains its oldest art. In the grand ballet of galaxies, even the smallest dancer has a role. Among the hundreds of billions of stars caught in the slow merging of the Milky Way and Andromeda, our Sun, a modest, middle-aged star on the outer edge of a spiral arm, will not escape the music of gravity. Its fate, and the fate of every world that circles it, will be determined by the quiet mathematics of motion, playing out on a scale almost too vast to comprehend. Right now, our solar system orbits the Milky Way's center at a distance of about 26,000 light-years, traveling at 220 kilometers per second. We make one full lap roughly every 200 million years. By the time Andromeda's approach becomes undeniable, the Sun will have completed 20 more revolutions, and it will be old. 5 billion years from now, it will be nearing the end of its main sequence, its hydrogen fuel thinning, its light slowly shifting toward red. When the galaxies begin to interact, their gravitational fields will reshape one another. The delicate balance that keeps our solar system anchored in its current orbit will change. The combined gravity of Andromeda and the Milky Way will tug at us, imperceptibly at first, then with growing insistence. Simulations suggest that our Sun, along with its planets, could be cast into a new orbit far from its present position, perhaps flung toward the outer halo of the forming Milky, perhaps drawn inward toward its glowing core. The uncertainty is immense, but the outcome is inevitable. The familiar sky will vanish. If the solar system is ejected outward, it may find itself drifting through the quiet edges of the new galaxy, a region sparse with stars, cold and empty. There, the Sun's light will be a tiny beacon in an endless night. Its only company, the faint golden glow of the galactic core millions of light-years away. Planets, if any still survive, will orbit faithfully, but their days will be dim and their nights eternal. Earth, if it remains at all, will be long stripped of oceans and atmosphere, its once blue surface baked to stone under the swollen Sunday. If, instead, the solar system is drawn inward, the experience would be entirely different. The sky would blaze with stars, so dense and bright that darkness itself would disappear. The gravitational tides near the center would distort orbits, pulling asteroids and comets into new paths. Collisions might become more common, meteors streaking across the skies of dead worlds. But still, the sun would persist aging, expanding, turning the color of molten copper as it enters its red giant phase. By that time, Earth's story will likely be over. The sun's expansion will swallow Mercury and Venus, and Earth may follow, reduced to dust and plasma in its parent's final outburst. The gas giants will drift outward, their icy moons thawing briefly in the rising heat before freezing again as the sun sheds its outer layers. What remains will be a white dwarf, a dense ember, no larger than Earth itself, glowing faintly amid the chaos of a new galaxy. Around it, the relics of our solar system asteroid fragments, frozen planets, the remnants of long-vanished worlds will continue to orbit in silence. And yet, in another sense, we will not be gone. The atoms that once made up our planet, our bodies, and our air will have already joined the cosmic tide. They will be carried away by solar winds, scattered by supernovae, absorbed into new stars and new worlds, forming amid the merger's fiery cradles. Perhaps, somewhere in Milky's distant future, a planet rich in oxygen and water will rise again, and beings of another kind will stand under their golden sky and wonder where they came from. If they trace their lineage far enough, they might find us in their chemistry, our ancient molecules humming in their veins. It's a comforting thought that the end of our solar system is not a disappearance, but a transformation. Nothing in the universe is ever truly lost. The sun's death will return its elements to the galactic ocean, hydrogen, helium, carbon, iron, to be used again in the endless act of creation. The collision that seems to spell destruction will, in truth, be part of an unbroken cycle. The rebirth of matter, the recycling of starlight. If a distant observer could watch this unfold, the solar system's journey would look almost graceful. It would drift from one orbit to another like a leaf carried by invisible wind. It would pass through waves of light and gravity, spinning, swaying, never colliding, always moving toward new balance. Even its dissolution would be serene, an evaporation rather than an explosion, one more quiet gesture in the vast choreography of the cosmos. The Milky Way once gave us life. Andromeda will give our dust a new home. Between them lies our true inheritance, not permanence, but continuity. To be human is to live in a fleeting moment between the birth of stars and their inevitable transformation. To understand our fate is to recognize that we are part of that transformation, that our story will continue long after the sun's last light fades. So when the time comes and our solar system drifts into the great merging sea of Milkomeda, there will be no final ending, only a transition. Our atoms will go on, our stardust will travel, and somewhere in the galaxy's endless expanse, the universe will begin again. And perhaps, in that far-off dawn, a new world will look up at its sky, glowing with the light of 1,000 inherited suns, and feel without knowing why that it has been here before. The story of Milkomeda is not just the meeting of stars, it's the meeting of histories. Two galaxies, each ancient beyond measure, carrying memories etched in starlight, will combine their stories into one. Every cluster, every nebula, every lonely wandering planet holds a record of its past. The Milky Way carries the tale of Earth, of our sun, of every civilization that looked up and wondered. Andromeda carries its own long silence, a history without witnesses, a beauty never seen. When they merge, these two vast archives of time will blend, creating a new chapter in the universe's autobiography. Imagine the oldest stars of Andromeda drifting into the Milky Way's halo crimson suns older than our planet. glowing faintly as they pass through regions that were once entirely foreign to them. Their light will mingle with the pale yellow of our own ancient stars, the faint blue of the newly born, and the silvery dust of collapsed nebulae. This blending is not just physical, it is historical, emotional, a fusion of everything that ever happened in both galaxies. Each photon of light that reaches the new galaxy's edge will carry a message written billions of years ago. Every galaxy is an archive. Its stars are words, its clusters are sentences, its structure is a kind of cosmic syntax. Over time, gravity edits the text, erasing some passages and rewriting others. When the Milky Way and Andromeda merge, they'll become a single cosmic language, the grammar of creation rewritten in light. The patterns of motion, the arrangement of clusters, and even the chemical compositions of the stars will reveal the signature of both parents. Astronomers of the distant future will be able to trace those fingerprints to know that Milky Way was once two galaxies, distinct yet destined to be one. Some of these signatures will linger in subtle ways. Andromeda's stars, rich in certain heavy elements, will tell of its long, slow evolution. The Milky Way's younger, more dynamic stars will speak of bursts of creation, of restless motion. Even the dark matter halos will remember their origins, their overlapping shapes preserving the gravitational echo of the merger. The universe forgets nothing. It only transforms its memories into new forms. It's humbling to think that our story, the human story, is a single thread woven into that greater fabric. The atoms that form your body were once scattered across both galaxies, born in the cores of long-dead stars. Some of them might have drifted through Andromeda's clouds billions of years ago, only to find their way here, to Earth. The universe doesn't separate its creations, it circulates them. What we call identity Milky Way, Andromeda, even human, is just a temporary shape carved from an unbroken continuum. In the merger, those identities dissolve. The borders blur, and what was once ours, or theirs, becomes meaningless. The stars don't care which galaxy they came from. They orbit the new center with equal grace. And perhaps there's a quiet lesson in that unity, in the cosmic sense, is not forced but natural. Left to itself, everything in the universe eventually finds harmony. As the galaxies settle, the differences between them will fade. Over billions of years, Milky Way will smooth into a perfect ellipse, a balanced structure glowing with calm uniformity. But deep inside, traces of the old spiral arms may still linger, faint filaments of stars, stretching outward like the ghosts of memory. Astronomers might call them tidal remnants, but they are more than that. They are the handwriting of history, still visible beneath the light. From a philosophical view, this merging is like the meeting of two souls, not in collision, but in recognition. The Milky Way and Andromeda have always been companions, orbiting each other in a slow gravitational embrace since the dawn of their existence. Their meeting is not a tragedy, but a return. It's as if the universe itself arranged this dance to remind us that separation is temporary and connection eternal. If one could compress billions of years into a single heartbeat, the formation of Milky Way would look like a bloom. Two spirals swirl inward, their arms twisting, their centers glowing brighter, until suddenly they blossom into a single sphere of light. It would be beautiful beyond description, a flower made of stars, unfolding in the dark. Some of the surviving civilizations, if they endure through this era, may record this transformation. They might trace the fading spiral arms across their skies, mapping the slow arc of Andromeda's descent. Perhaps their myths will tell of two great beings, lovers, gods, or titans, finally finding each other after an eternity apart. In truth, that's not so far from what's really happening. For in cosmic terms, gravity is love, the force that binds, that draws together, that keeps things from falling apart. When the merger is complete, Milky will be a time capsule of everything that came before. Its light will shine across the universe long after the memory of human civilization has faded. Our messages, our music, our tiny radio signals will drift between the stars for a while, but eventually they'll fade into the background hum of radiation. Still, our atoms, our dust, our essence will remain. The story of Earth will be part of Milky's story, written not in words, but in matter itself. And so, the merging of cosmic histories continues the pattern that began long before us: separation, encounter, and union. It is not destruction, it is remembrance. It is not loss, it is transformation. The stars will forget their names, but not their belonging. In the end, there will be no Milky Way and no Andromeda, only Milky, glowing softly in the infinite dark, a single memory made of light. Ours is not the first story of merging galaxies, nor will it be the last. Across the cosmos, collisions like the one awaiting the Milky Way and Andromeda are happening everywhere, all the time. Some are slow and elegant. Others are wild, chaotic, almost violent in their beauty. Every one of them leaves behind an echo, a glowing scar of light, a tidal tale of drifting stars, a memory written in the shape of the sky. And by studying these distant collisions, we catch glimpses of our own future. If you look through a telescope at the constellation of Corvus, you'll find one of the most famous galactic mergers, the antennae galaxies. From 60 million light-years away, they appear as two brilliant cores surrounded by long, curving arcs of stars, immense tidal tails reaching out like insect limbs. Those tails are the result of gravitational stretching as the galaxies pull on each other. Within them, star formation rages. Clusters of newborn suns light up the scene like cosmic fireflies. If you could watch them in motion, you would see waves of color rippling across the dark, like bioluminescent currents in an ocean of night. Farther away, in the constellation of Canes Venatici, lies another spectacle, the Whirlpool Galaxy, or Messier 50-1. This one is still in the early stages of merging with a smaller companion galaxy. You can see the dance frozen in time, the larger spiral's arm twisting toward its partner, threads of gas and dust connecting them like bridges of silk. The smaller galaxy is being slowly devoured, its stars absorbed one by one. Yet from this quiet consumption comes creation. Glowing pink nebulae mark where new stars are being born. It's as if destruction and birth have found perfect equilibrium. Then there is NGC 4676, known as the Mice. Two slender galaxies stretch past one another, leaving trails of stars that extend for hundreds of thousands of light-years. They look like tails, flicked in slow motion. This collision is so delicate that the galaxies haven't yet merged completely. They are still circling, entwined but not united, like dancers hesitating before a final embrace. In a few billion years, they too will fuse, leaving behind a single, luminous form. Each of these cosmic encounters tells a part of the same universal story that gravity is both artist and author. It paints the galaxies with light, stretches them into curves and arcs, and then gathers them again into new shapes. No two collisions are identical, but all follow the same underlying rhythm: approach, interaction, merger, and calm. The universe repeats this dance endlessly, sculpting beauty from inevitability. For astronomers, these galactic collisions are time machines. They show what has happened countless times before and what will happen to us. The antennae reveal the chaos of the first approach, the violent creation of new stars. The whirlpool shows the slow courtship between two uneven partners. The mice demonstrate the tension of near misses, the tidal tearing that precedes fusion. By comparing them, we can see where the Milky Way and Andromeda fit in the grand sequence. Right now, we're still in the distant approach, the quiet before the dance. But the outcome is written, and there are others. Some mergers are so advanced that their original shapes are long gone. Centaurus A, for instance, is a galaxy scarred by its past. It looks distorted, as if bent by invisible hands, its central region glowing with the energy of a supermassive black hole that still feeds on the remnants of a smaller galaxy. From its poles, immense jets of plasma shoot out for thousands of light years, illuminating the void with radio waves. Centaurus A is what the Milky Way and Andromeda may one day resemble, a galaxy transformed, serene on the outside, but holding traces of old fires deep within. We even see echoes of collisions from billions of years ago, light from galaxies that merged before Earth existed. Their images reach us now as faint smudges, their light stretched and softened by time. They remind us that the universe has been practicing this art of merging since its earliest days. Galaxies have always been travelers, drawn together by gravity's subtle call. Some were torn apart, others found harmony. In their aftermaths, the cosmos grew richer, filled with more stars, more worlds, more chances for life to bloom. There's a strange comfort in knowing that what we face is not unique. The merging of the Milky Way and Andromeda is part of a pattern older than the stars themselves. Every time two galaxies meet, the universe becomes slightly more ordered, slightly more beautiful. It's as though creation learns from its own experiments, smoothing its edges, refining its designs. The collisions that seem catastrophic are, in truth, acts of cosmic evolution. If you could listen to the universe, perhaps you'd hear the rhythm of these events, a faint cosmic heartbeat, pulsing with each merger. The intervals between beats are measured not in seconds, but in billions of years. To us, it feels eternal. To the universe, it's a steady rhythm, ancient and unbroken. Each pulse is another galaxy meeting another act of becoming. And when you look up at the night sky even now, before the Milky Way and Andromeda have touched, you are already seeing the results of those long-ago collisions. Every bright star you see was forged in such an event, every nebula shaped by remnants of one. Even our own sun may be a child of a past merger, its birth sparked by a shockwave from some ancient galactic encounter. So, when our turn comes, it will not be an ending, but a continuation of that timeless song. The echoes of other collisions have already prepared the way. They've shown us that out of chaos comes light, out of movement comes grace. The antennae, the whirlpool, the mice, these are our mirrors, showing us what awaits. And when, billions of years from now, Milky shines in the dark like a single golden lantern, it will be one more echo, one more harmony in the infinite symphony of galaxies becoming whole. In the quiet heart of every massive galaxy, a black hole waits, invisible, patient, powerful. It is not a monster devouring stars in chaos, but a sculptor shaping the very structure of its host. Though it occupies no more than a point in space, its influence stretches across light years. Every orbiting star, every drifting cloud of gas, every spiral arm owes something to its pull. Without black holes, galaxies as we know them might not exist. When we speak of black holes, we often imagine destruction, light swallowed, matter torn apart, time itself distorted. But this is only half the truth. In the language of the cosmos, black holes are not merely consumers, they are regulators. They maintain balance between creation and collapse. They feed, yes, but they also give. Every time they consume matter, they release energy in the form of radiation, magnetic storms, and jets of plasma that stretch beyond imagination. These outflows carve the galaxy's structure, stirring the interstellar medium like a spoon swirling cream in coffee. In the early universe, this process was vital. Young galaxies were chaotic, turbulent clouds of gas, endless collisions, and frantic star formation. Left unchecked, they would have burned through their gas too quickly, collapsing into exhaustion. But black holes acted as governors, their energetic feedback slowing the pace. When they accreted too much matter, they ignited, releasing winds and radiation powerful enough to blow away the surrounding gas, halting star formation for a time. When the gas cooled and fell back, the process began again. This cycle, feeding, releasing, resting, gave galaxies rhythm. It made them sustainable. Our own Milky Way's central black hole, Sagittarius A*, has lived through this dance for billions of years. Today it rests quietly, but in its youth, it likely flared as a quasar, a beacon so bright it could outshine the entire galaxy. During those active phases, streams of charged particles shot outward from its poles, illuminating vast regions of space. Even now, astronomers can see the afterglow, enormous bubbles of gamma rays rising above and below the Milky Way's plane, like faint footprints of an ancient fire. They are reminders that our galaxy's calm heart once burned with unimaginable fury. In Andromeda, a similar story unfolds. Its central black hole, far larger than ours, also shaped its home galaxy's destiny. When the two galaxies finally merge, these two cosmic architects will meet not as destroyers, but as builders. Their dance will decide the future structure of Milky. As they spiral closer, their combined gravitational pull will reorder the orbits of billions of stars. The galaxies will settle into a smoother, rounder shape, their energy distributed more evenly. And when the black holes finally merge into one, the gravitational waves they release will ripple across space-time, forever marking the moment when two hearts became one. It's strange to think that something so destructive can also be the source of order. Yet that duality defines much of the universe. Creation and annihilation are not opposites here. They are partners. Black holes teach us that what disappears is never truly lost. The matter and energy they consume are not erased, but transformed, their presence written into the shape of the galaxy, their power preserved in the orbits of stars and the glow of new suns. Consider this. Every atom in your body once belonged to a star. That star, in turn, may have been born from gas stirred by a black hole's ancient outburst. The iron in your blood, the calcium in your bones, the carbon in your breath, all of it may have passed through the invisible influence of a black hole before finding its way here. You are, in a very real sense, part of their quiet legacy. Scientists studying galaxies across the cosmos have discovered a curious relationship known as the M-sigma relation. It links the mass of a galaxy's central black hole to the speed at which stars move within it. The larger the black hole, the faster the star's orbit. This connection suggests an intimate partnership. Galaxies and black holes grow together, each shaping the other. It's a relationship not of dominance, but of mutual dependence. A cosmic balance written in gravity's invisible ink. When the Milky Way and Andromeda merge, their black holes will carry out this dance on the grandest scale. For hundreds of millions of years, they'll orbit one another like twin suns, drawing closer with each revolution. Their combined gravity will stir the galaxy's core, igniting waves of star formation and reshaping the flow of matter. Eventually, friction from surrounding gas and the emission of gravitational waves will cause their orbits to decay. When they finally meet, the result will be one colossal black hole, perhaps 10 times more massive than either alone. To a distant observer, this moment would look like a flash of invisible brilliance. The merging black holes will release an enormous burst of gravitational energy, space-time itself flexing and ringing like a struck bell. These waves will travel across the cosmos, distorting everything they pass through ever so slightly. Billions of years later, faint detectors on faraway worlds may still record those ripples, unaware that they are listening to the final heartbeat of two ancient galaxies becoming one. Afterward, Milky will rest, its central black hole, now titanic, will dominate the core but remain quiet, feeding slowly, content in its enormity. Around it, stars will orbit in graceful ellipses, bound by an invisible tether. The galaxy will glow softly, its structure smooth, its energy balanced. And perhaps that's the most poetic truth of all. The same force that devours light also gives shape to beauty. Black holes, for all their mystery, are not the universe's end, but its beginning, its architects, its keepers of rhythm. They are proof that even in the darkest places, something vast and ordered persists. If you ever feel small beneath the night sky, remember this: you are part of that order. You are made of remnants that once danced around a black hole, dust that once glowed in a star ignited by their storms. You are not apart from the cosmos, but an echo of its most ancient design. And someday, when Milkymeda's heart beats as one, its light fading slowly into eternity, the memory of those black holes will remain not as monsters in the dark, but as the quiet architects of everything that ever was. There is an old idea, older than astronomy itself, that the cosmos has a song. The ancient Greeks called it musica universalis, the music of the spheres. They imagined that each planet, each star, each celestial body produced a note as it moved through the heavens, and that together these notes formed a grand cosmic harmony. To them, it was not a literal sound, but a metaphor for order, a reminder that even chaos, when seen from afar, might reveal a deeper rhythm. Today, we know that space is mostly silent. There is no air to carry sound waves. But the idea of cosmic music was never wrong, only misunderstood. The universe does sing, just not with sound. It sings with gravity, with light, with motion. The rhythm of its expansion, the pulses of stars, the waves that ripple through space-time, all of these are its notes. And if we could translate those invisible frequencies into something we could hear, the result would be a song older than time, soft and endless, filling every corner of existence. Imagine this music not as noise, but as vibration, the kind that hums quietly beneath everything, from atoms to galaxies. The spin of electrons, the orbit of planets, the oscillation of stars, each adds its own subtle tone. The slow undulation of merging galaxies forms the baseline, deep and resonant. The flicker of newborn stars, bright and brief, adds the treble. And somewhere in the middle, between the macro and the micro, lies the melody of life, delicate, irregular, full of improvisation. If you could stand in the heart of Milkymeda billions of years from now and listen, truly listen, you might hear it. Not with your ears, but with your awareness, the gravitational symphony that binds the galaxy together. Stars orbit in chords, gas clouds collapse in crescendos, supernovae burst like cymbals struck at the end of a phrase. Even the black hole at the center plays its part, emitting gravitational waves that ripple like a deep drumbeat through the fabric of space-time. Every movement, every vibration is part of the same unending score. In recent decades, astronomers have found ways to hear the universe. They take data, the changing brightness of a star, the spin of a pulsar, the waves from colliding black holes, and convert them into sound. When they do, the result is haunting. A black hole collision becomes a brief, rising chirp, like a raindrop falling on a drum stretched across eternity. Pulsars tick with steady precision, a cosmic metronome. Quasars hum softly in the background, the static of creation itself. The universe, it turns out, has always been humming. We just needed new instruments to notice. Even silence, out there, is not truly empty. The cosmic microwave background, the faint afterglow of the Big Bang, carries with it tiny fluctuations, echoes of the universe's birth cry. If we could amplify those fluctuations into audible sound, we'd hear a long, low tone, something like a breath drawn and held for billions of years. Every galaxy, Every cluster, every strand of cosmic web vibrates in harmony with that original note. It's not noise. It's the residue of creation, the universe, remembering how it began. The ancients were right in spirit. The music of the spheres is not something you can hear, but something you can feel. It's the harmony between order and chaos, expansion and gravity, birth and decay. Every time a galaxy spins, every time a planet orbits its star, it participates in that ancient rhythm. You are part of it too. Your heartbeat, your breath, your sleeping rhythm, all are echoes of cosmic motion. The atoms inside you vibrate with the same frequencies that once rippled through the early universe. You don't just live in the cosmos. You are the cosmos, temporarily arranged into awareness. Sometimes, when astronomers study distant galaxies, they notice patterns in the light, regular pulsations, slow waves of brightness fading in and out. They call these variations oscillations, but if you were to think of them musically, they are like notes in an infinite scale. The light from stars flickers like a chord. The pulses of quasars beat like drums. The gravitational waves from merging galaxies hum in frequencies too low for us to hear. Together, they compose something no orchestra could ever replicate, a melody that stretches from one end of the universe to the other, timeless and unbroken. And what happens when galaxies merge, as Andromeda and the Milky Way are destined to? Their music changes, their rhythms align. The two great structures of light begin to resonate with one another, gravity tugging in time like dancers, synchronizing their steps. The result is a new chord, richer, deeper, more complex. The merger is not just a collision of matter, but a blending of sound, the universe's own improvisation. It's beautiful to think that when the galaxies finally become Milkomeda, the cosmos itself will adjust its pitch. The gravitational waves released by the merging black holes will ripple outward, altering the universal harmony by the slightest fraction. Somewhere, far beyond our reach, another galaxy may tremble in response, ever so slightly. Like a note reverberating across a piano string, the sound of our union will travel through the dark forever. Perhaps this is what makes the night sky so calming to us. Somewhere deep down, we sense that rhythm, the balance of movement, the slow unfolding of order. We feel it in the tides, in our heartbeat, in the way we breathe in sync with the world. The universe is not silent, and neither are we. Every atom, every cell hums with its vibration. We are participants in the music of the spheres, dancers in its endless tempo. And when we look up, we are not just gazing at light, we are listening quietly, unconsciously to the oldest song there is. To understand the collision between the Milky Way and Andromeda, you must first let go of time as you know it. Human time is measured in breaths, heartbeats, the turn of seasons, the passing of generations. Cosmic time is not like that. It moves in oceans, not rivers. It stretches so wide that even eternity, to us, would seem like a single moment within its tide. 4 billion years until the collision, the number feels incomprehensible, almost poetic in its distance. But to the universe, it's only the blink of an eye. Imagine watching the clock of creation. Every tick lasts 1 million years. You would see continents drift like clouds, mountains rise and crumble like sandcastles, entire species appear and vanish between one breath and the next. Civilizations, ours included, would flare and fade like sparks in a storm. And above it all, the stars would move at their own patient pace, unbothered by the urgency of the tiny creatures beneath them. The Milky Way and Andromeda have been moving toward each other for nearly the entire history of life on Earth. When the first single-celled organisms drifted in the oceans, the two galaxies were already falling together. When dinosaurs thundered across the land, the distance between them had already shrunk by a fraction of a cosmic inch. And now, as humans send telescopes into the dark, we can finally see what's been happening all along a journey of unimaginable scale, unfolding too slowly for any eye to witness. To the universe, time is elastic. Gravity bends it. Speed stretches it. The deeper you fall into the pull of mass into the heart of a galaxy or the embrace of a black hole, the slower time runs. 1 billion years out here might be a single heartbeat there. The collision of galaxies will unfold differently, depending on where you stand. To an observer at the edge of Milky's future halo, it might look like a slow ripple. To someone near its merging core, it might seem like a single, eternal moment, two galaxies folding into one, forever mid-embrace. This idea, that time itself changes depending on where you are, is one of the universe's quietest wonders. We like to think of time as a straight line, moving from past to present to future. But in truth, it's more like the surface of a river, curved, disturbed, and influenced by everything it touches. Galaxies, black holes, stars, all of them are pebbles dropped into that flow, each sending out its own pattern of ripples. When the Milky Way and Andromeda merge, their combined gravity will warp space-time across millions of light years. Time will literally bend under their weight. In a way, this means that the story of their collision is already happening everywhere, all at once. Some of its light is reaching us now. Other parts will not be seen for billions of years. The universe doesn't unfold neatly in order. It's more like a great canvas being painted from every direction at once. What's past and what's future are relative. Somewhere, perhaps in a region of space-time warped by a distant black hole, the merger has already happened. Somewhere else, it is still only beginning. For humans, bound to our brief lives, this can feel disorienting. We crave beginnings and endings. But the cosmos does not deal in endings, only in continuations. Stars are born, die, and scatter their elements to form new stars. Galaxies collide, merge, and bloom again in new forms. Even when the last light fades, when the universe grows dark and cold, that too will only be another phase in an endless transformation. If you could live long enough to witness the collision, truly witness it, you would see the galaxies approach each other faster and faster as gravity takes hold. The night sky would fill with Andromeda's stars, glowing brighter each millennium. Then, for millions of years, the two galaxies would seem to hang together, suspended in light. You would see arcs of stars stretching across the heavens like bridges of gold. But you would not hear it, not feel it, not be able to measure its speed. The event would last longer than the history of your species. It would feel infinite. Eventually, the merger would complete, but by then, billions more years would have passed. The sun would be long gone. New stars, new worlds, new forms of life might have emerged to gaze upward and call that glowing sky their own. For them, the collision would not be a story from the future, but an ancient myth. They might look into the sky of Milky and see faint ripples in the starfield, the last echoes of the galaxies that birthed their home. And in time, even those ripples will fade. The orbits will stabilize. The stars will drift in quiet harmony. The memory of the collision will remain, but only in the way a tree remembers wind in the shape of its branches, the subtle curve of its trunk. Time, ever patient, will smooth everything. What once was chaos will become symmetry again. When we think of billions of years, we imagine emptiness, cold, and decay. But to the universe, that span is fertile. It's the space in which galaxies grow, stars mature, and life learns to look back. We are part of that rhythm, even if our part lasts only a verse or two in the song. So when you think of 4 billion years, when you imagine Andromeda and the Milky Way finally touching, remember this: time does not belong to us. We borrow it for a moment, then pass it back to the cosmos. We are witnesses, not owners. And though our time is short, we live inside a story that stretches forever. Each moment, each heartbeat, is a fragment of eternity made visible. Even when our world fades, the universe will continue to unfold slow, serene, unending. That is the nature of cosmic time. It does not pass, it simply is. If you step back far enough, farther than any telescope or spacecraft could ever travel, something astonishing becomes clear. The universe is not just being observed, it is observing itself. Every mind that has ever wondered about the stars, every consciousness that has ever looked up at the night sky, is the universe peering inward. The Milky Way, Andromeda, and all the galaxies beyond are not simply objects of beauty. They are reflections of a grand awareness awakening within matter itself. This is perhaps the most profound realization of all, that the cosmos has grown eyes through us. It has developed the means to contemplate its own existence, to measure, to imagine, to dream. Through our thoughts, the universe gains memory. Through our questions, it gains meaning. In every human gaze turned skyward, something ancient and vast looks back. When Andromeda and the Milky Way collide, there will be no witnesses in the traditional sense. Humanity, as we know it, will almost certainly be gone. The sun will have aged, the earth long transformed. Yet, the universe may not be empty of awareness. Somewhere in the wide reaches of the merged galaxy, another form of consciousness may have risen. Perhaps it will look different, crystalline, cloud-like, artificial, or biological, beyond recognition. But it will do the same thing we once did: look up, wonder, and ask why. It may not even know that what it perceives as a single galaxy, Milky was once two. It may not remember the small blue world where life first realized it was part of something infinite. But memory doesn't need to be conscious to endure. The evidence of our existence will be written into the light itself, in the metals of distant stars, forged from our sun's ashes, in the dust drifting through space that once formed our bones. Even if no one remembers us, we will have fulfilled the universe's oldest impulse, to know itself. That is the quiet purpose hidden beneath every atom's vibration. From the birth of the first star to the merging of galaxies, the cosmos has always been moving toward complexity, toward reflection. Matter becomes life, life becomes mind, and mind, in turn, gazes back upon matter and says, "I see you." There is poetry in that asymmetry as graceful as any orbit. The universe creates observers who, by observing, complete the circle. Light leaves a star, travels for billions of years, and finally falls upon an eye, a lens, a sensor. In that instant, the journey of that photon is fulfilled. Its existence becomes known. Every act of observation, every moment of awareness, is a bridge between the physical and the divine. We tend to think of ourselves as small, fragile, transient, and yet, through us, the universe achieves something eternal: consciousness. Perhaps it happens everywhere, in every galaxy, every world where conditions align. Perhaps it happens rarely, a cosmic rarity flickering briefly before fading. Either way, the pattern is unmistakable. The cosmos is not indifferent. It produces awareness again and again, as if unable to resist the urge to see its own reflection. And maybe that's what the merger of Andromeda and the Milky Way truly represents: not just a physical union, but a symbolic one. Two galaxies, two vast systems of matter and light, coming together not only to form a new structure, but to deepen the universe's understanding of itself. Within Milky, new worlds will form. Around some of those worlds, life will arise. And among some of that life, minds will open minds, capable of awe, curiosity, love, and fear. Minds capable of asking what we asked. Where did we come from? Why are we here? These future observers will not know us, but they will continue our work. They will study their skies, trace the faint glow of the galactic core, and invent myths to explain what they see. They might send messages into the dark, hoping someone else is out there. They might build instruments to detect gravitational ripples, the faint echoes of the ancient merger that birthed their home. And one quiet night, one of them might realize that they too are the cosmos looking inward. From that perspective, the universe's story is not a cold one. It is deeply intimate. The light of stars, the pull of gravity, the chemistry of life, all of it conspires toward awareness. The cosmos wants to be known. Every atom that binds to another, every star that forms, every galaxy that collides, all of it is movement toward a single, infinite act of recognition. And in that realization lies comfort. Even if we vanish, we have already fulfilled our role. For a brief moment, consciousness bloomed here. We named the stars, charted their courses, and understood a fragment of their music. The universe, through us, has already witnessed its own reflection, and it will do so again, somewhere, sometime, in some form we cannot yet imagine. The thought is almost tender, that awareness is not local, not personal, but cosmic. We are notes in the same chord that hums through galaxies. And as those galaxies merge, as Milky takes shape, that chord deepens. The universe continues to listen to itself, to sing to itself, to dream of its own becoming. So when you look at the night sky, even now, across the billions of years that separate you from that future, remember that you are part of the observer and the observed. You are the mirror and the reflection, the eye and the star. The universe is not silent, it is watching through you. When the final ripples of the great collision fade, when the last arcs of starlight settle into calm, the universe will fall quiet again. The Milky Way and Andromeda will no longer exist as separate spirals of light. Their dust, gas, and stars will have become one woven into a single, serene shape that glows like a slow-burning ember against the velvet dark. Out of ruin, something new will have been born. In the beginning, it will still look chaotic. Tidal streams will twist around the newborn galaxy like ribbons of silk, drifting in invisible wind. Stars will move in wild orbits, tracing luminous spirals across the void. Clouds of gas will still collide, and blue newborn suns will flare to life across the tangled arms of the merger. But slowly, over billions of years, that turbulence will ease. The bright, distinct spirals of youth will smooth into a gentle ellipse, the hallmark of a mature galaxy. The stars will settle into harmony again, and the chaos of collision will fade into equilibrium. Milky will shine brighter than either of its parents did, at least for a time. Billions of suns, once scattered across two galaxies, will now share a single gravitational rhythm. Their combined light will spread outward in soft golden waves, bright enough to illuminate the void for millions of light years around. From a distance, the new galaxy will resemble a lantern suspended in infinite darkness, a quiet beacon of balance, born from cosmic upheaval. But beauty always comes with transience. After the merger, the rate of new star formation will slow. The gas and dust that once fueled the birth of suns will thin, exhausted by the intense activity of the collision. The hot, young stars that burn blue will live fast and die quickly, leaving behind redder, older stars that glow dimly for eons. Over trillions of years, Milky will shift from gold to amber to faint crimson, its light aging along with its stars. The galaxy's heart will remain brilliant for longer, fed by the gravity of the merged black hole at its center, a vast and silent heart that still beats with the memory of two galaxies long gone. If you could stand somewhere inside Milky on a world orbiting a stable star, perhaps billions of years from now, you might find the night sky almost overwhelming. The horizon would be crowded with light. The core of the galaxy would stretch like a golden sea overhead, its brightness enough to erase true darkness. Stars would no longer be pinpricks, but blazing points of fire scattered across the heavens. To any being that evolved there, the idea of an empty sky would be unimaginable. Yet even then, change would continue. Gravity would keep reshaping the stars' orbits, drawing them closer toward the central black hole or flinging them outward into intergalactic solitude. Every few million years, a dying star would collapse into a supernova, briefly outshining everything around it before fading into the quiet hum of background starlight. Nebulae would expand and dissolve. Entire clusters would drift apart, and the edges of the galaxy would blur into the endless dark. It may seem melancholy to imagine this fading, but in truth, it is not an ending. It is renewal in another form. The atoms forged in these final suns will travel outward, carried by stellar winds, scattering across the universe like seeds. One day, in some distant corner of space, those same atoms may gather again, forming new stars, new planets, perhaps even new life. The universe wastes nothing. It transforms everything. In this way, the collision between the Milky Way and Andromeda will echo across eternity. Its dust will become the dust of new worlds. Its light will become the starlight of new skies. The energy of its merging black holes will ripple forever through space-time, faint but eternal. Even when the galaxies themselves have long faded, the memory of their union will remain a vibration embedded in the structure of the cosmos, as enduring as gravity itself. Billions of years beyond that, when the last stars of Milky Way have burned out, the galaxy will fall into true stillness. The night will no longer shine. Only the massive black hole at its center will remain, devouring what little matter drifts too close, glowing faintly as it feeds. Then even that glow will vanish. And yet, in that final darkness, the energy, the matter, and the patterns born from this collision will still exist, scattered but not gone. The universe does not destroy. It recycles, it renews. Each collapse feeds a new creation. Every death gives rise to a new form. The merger of galaxies, no matter how grand, is simply part of that eternal breath, the inhale and exhale of existence itself. So perhaps, in that far future, when the last photon from Milky Way drifts across the empty dark, it will carry a quiet message that nothing is ever truly lost. Not light, not matter, not even memory. The stars die, but their atoms endure. Galaxies merge, but their essence continues. Life fades, but consciousness reappears somewhere else, in some new form, gazing upward again. We call it collision, but what it truly is continuity, a never-ending rebirth. And maybe that's the greatest comfort of all, to know that even after every galaxy has fallen silent, the universe will still hum softly to itself, dreaming of the next dawn.